Hello students, in today's session we are going to study about molecule. So the smallest particle of a compound which is able to exist independently is termed as molecule. Molecule is the smallest particle of a compound and it exists independently. Some elements exist as diatomic molecules such as O2, triatomic molecules such as O3. So in general, if we say group of two or more atoms that are chemically bonded together, that is tightly held together by attractive forces, is termed as molecule. Molecule is a group of two or more atoms that are chemically bonded together, that is tightly held together by attractive forces. And a molecule can be defined as the smallest particle of an element or a compound, which I told you just now. Smallest particle of an element or a compound that is capable of an independent existence, and it shows all the properties of that substance. So here we give the two definitions of molecule. First, a group of two or more atoms that are chemically bonded together, that is tightly held together by attractive forces. Second, the smallest particle of an element or a compound that is capable of an independent existence, and it shows all the properties of that substance. Then atoms of the same element or of different elements can join together to form molecules. So atoms of same element or different elements, they can join together to form molecules. Then just now which I told you, some elements exist as diatomic molecules and some as triatomic molecules. So if I say the molecule of an element are constituted by the same type of atoms, the molecules of an element, they are constituted by same type of atoms. So molecules of many elements such as argon, helium, etc., they are made up of only one atom of that element. So if we see argon, helium, they are made up of only one atom of that element. But this is not the case with most of the non-metals. If we see the non-metals, a molecule of oxygen consists of two atoms of oxygen, and hence it is known as diatomic molecule, O2, as I told you in this. So a molecule of oxygen consists of two atoms of oxygen atom. So hence we call it as diatomic molecules. If three atoms of oxygen unite in a molecule instead of the usual two, we get ozone, O3. Here the number of atoms constituting a molecule is known as its atomicity. So the molecules which consist of if three atoms of oxygen, they unite to form a molecule, then we get ozone, that is O3. It is diatomic molecule. Now atomicity. Atomicity is the number of atoms in a molecule of an compound. The number of atoms that are present in a molecule, we term it as atomicity. So elements are monoatomic, so having only one atom of its in a molecule of a compound. Diatomic, having two atoms in a molecule of a compound. Then it have triatoms. Triatoms means three atoms in a molecule of a compound, and polyatomic means more than three atoms. Compounds, atoms. Now we'll study about compounds. So If we see some of the examples, if you look at table 3.3 of page number 36 in your textbook, there are given the atomicity of some elements, that is some of the non-metals it is given. Argon, which is monoatomic, helium, which is monoatomic, oxygen diatomic, hydrogen diatomic, nitrogen, which is diatomic, chlorine diatomic, phosphorus tetraatomic, means it is having 4 atoms, and sulfur, which is polyatomic. Now we will study about compounds. Compounds are the atoms of different elements combined together in definite proportion. They form the compound. Atoms of different elements combined together in definite proportion to form a compound. So, for example, if we take water, in water the combining elements are, example, if I take water, that is H2O. So the combining elements are hydrogen and oxygen. So, and the ratio by mass is 1:8. For hydrogen, the ratio water, the ratio by mass is 1:8. Another thing if I take is ammonia, NH3. Then here the combining elements are nitrogen and hydrogen, and the ratio is 14:3. Another, if I take carbon dioxide, CO2, so the combining elements are carbon and oxygen, and the ratio is 3:8. So here the ratio by mass of for hydrogen and oxygen is 1:8. So the atomic mass will be 1 and 16. Mass ratio by atomic molecule. That time we will get the simple ratio. Atomic mass, you will know that the atomic mass of hydrogen is 1 and for oxygen is 16, and the ratio by mass is for 1:8, 1 for hydrogen and 8 for oxygen. So if you want to calculate the ratio by number of atoms for water, that is for hydrogen and oxygen, simple ratio, what you will do, mass ratio by atomic mass. Mass ratio for hydrogen is 1, atomic mass for hydrogen is 1, so 1 by 1 is equal to 1. Then mass ratio for oxygen is 8, and atomic mass of oxygen is 16. So 8 by 16, 8 divided by 16, that is 1 by 2. So here the simple ratio will be 2 and 1, that is 2:1. Now we will study about atoms and ion. What is an atom and ion? If we talk about ion, about atom we have already studied. Till now we were studied about atom only. But what is an ion? Atom and ion, they both are interrelated to each other. So an atom that bears a charge is called an ion. An atom containing a charge is called as an ion. So you all know generally that compounds are composed of metals and non-metals, and they contain charged species. Now the charged species are known as ions. These charged species we term as ions. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. So ions can be ions may consist of a single charged atom, means there will be only one atom which consists of only one charge, or there will be group of atoms which consist a net charge, means all the atoms having a total charge on them. An ion can be negatively charged also and positively charged also. A negatively charged ion is called as an anion, and the positively charged ion is called as a cation. Now we will study about cation. So they are positively charged ions. Just now we studied they always lose electrons and have electrons less than those in a neutral atom. They always lose electrons, so obviously they will be having less electrons than the neutral atom. So if we talk about NaCl, in NaCl, Na plus is positively charged, right? So it always is loose electrons, and that have electrons less than those in neutral atom as compared to chlorine. Now if we talk about anion, they are negatively charged ions. They always gain electrons and they have electrons more than in a normal atom. Suppose if we talk about Cl minus, chlorine. Then if we talk about valency, valency is the combining capacity of an atom, and it depends upon valence electrons. It depends upon the valence electrons. So if we take valency, it can be used to find out how many atoms of an element are will combine with the atoms of another element to form a compound. So it can be thought of as hands or arms of that atom. Valency hands can be thought as hands or arms of that atom. So if example, if I take the human beings have 2 arms and an octopus has 8, right? So if one octopus has to catch hold of a few people in such a manner that all the 8 arms of octopus and both arms of all the humans are locked, how many humans do you think the octopus can hold? So represent the octopus with O and humans with H. Okay, octopus O, humans H. Now, can you write the formula for this combination? So, do you get octopus has 8 arms, means only one octopus, and 2 hands each of humans. So, means in his 8 arms, 4 humans, 4 hands of the humans will be occupied. So, do you get OH4? OH4 as a formula. Now the subscript 4 indicates the number of humans held by octopus. 4 humans are held by the octopus, right? So the valencies of some common ions are given here in the table 3.6, which is on page number 37 of your textbook. And if you about this valency we will learn in detail about in the next chapter. Here only a brief explanation is given about the valency. So valency here of sodium, potassium, silver and copper is 1, magnesium, calcium, zinc, iron and copper 2, that is 2, and aluminium and iron 3, it is 3. About this we will learn that how this valencies are, how can we know that what the valency of sodium is 1, potassium is 1, how will we know that? About this we will learn in the next chapter. Now, some elements have fixed valencies and some have variable valencies, that is 2 or more than 2 valencies. So but how can we see it that which are having 2 valencies, which have 1 valency? So the valencies or charges on the ion must balance, it must be balanced. So if you talk about sodium, no, not sodium, copper, there are 2 forms of copper 1, copper 2, right? The copper 1 is Cu plus, it will be having different valence, it have valency 1. Copper 2 is Cu2 plus, it is having valency 2. Means different elements, some elements have fixed valency, but different elements, some of them have more than 2 valencies. Then if you talk about iron 2, that is Fe2 plus have valency 2, and iron 3, that is Fe3 plus have valency 3. This way we get the valencies. But how can we determine the valency of an compound that we will study in the next chapter in detail. There you will be knowing, you don't have to learn the valencies. I will teach you how to calculate the valency, how to find out the valency in a very simple manner. So for today it's only this much. In the next lecture we will further see this chapter. Thank you and have a great